IBM just gave enterprise technology leaders a warning, but it may not be the warning everyone thinks it is. On July 14th, IBM released preliminary financial results more than a week before its scheduled earnings call. Revenue was expected to reach $17.2 billion, growing only 1% year over year. Software revenue grew 5%, consulting was essentially flat, infrastructure revenue declined 7%. IBM also acknowledged that it had underestimated how quickly customers were redirecting spending towards servers, storage, memory, networking, and urgent cybersecurity requirements. The market reacted immediately. IBM's stock fell roughly 25%, and the announcement intensified an already uncomfortable question across the technology industry. Is artificial intelligence beginning to consume the software market that helped create it? Are we heading toward what some investors are calling a SaaS-pocalypse, where AI agents generate custom tools, automate knowledge work, and weaken the value of traditional software subscriptions? Possibly. But I believe that interpretation is too simple. AI is not killing software. AI is reordering the enterprise technology stack. And that distinction matters because companies that misunderstand this shift could spend millions of dollars on AI infrastructure without ever changing how their businesses actually operate. Hi, I'm Jory Pai. I'm an application modernization and AI transformation executive, and I've spent more than 2 decades helping large organizations navigate major shifts in enterprise technology. Today, I want to talk about what may be one of the most important shifts happening right now. AI is not simply replacing software, it is reordering the entire enterprise technology stack and changing how leaders need to think about applications, agents, data, infrastructure, and human judgment. Let's break down what that really means. For decades, most business behavior was encoded inside applications. A company purchased or developed an application for accounting, claims processing, customer service, supply chain planning, healthcare billing, sales, or human resources. Developers translated business policies into code. Employees navigated menus, screens, and forms. Databases stored the official record. Integrations moved information from one system to another. The operating model was relatively straightforward. People used applications. Applications executed predefined rules. Databases preserved the result. That model is not disappearing. Deterministic software is still exceptionally good at work that must be repeatable, precise, fast, auditable, and secure. A language model should not casually improvise your general ledger. It should not invent an inventory balance, change a patient's medical record, approve a wire transfer, or modify a regulated financial report because it believes that is probably the correct next step. Systems of record will remain essential. Payment platforms will remain essential. Databases, authentication services, ERP platforms, core banking systems, clinical systems, and regulatory reporting applications will remain essential. What is changing is that applications are no longer the only place where business behavior can live. AI agents can interpret an objective, gather context, choose tools, call APIs, coordinate subtasks, evaluate intermediate results, and adjust their actions. That creates a different enterprise operating model. People establish objectives, policies, and authority. Agents coordinate adaptive work. Applications execute trusted functions. Data systems preserve institutional memory and transactional truth. The agent does not necessarily replace the application. It becomes a new behavioral layer across the application landscape. Consider a customer service issue. Today, an employee may need to open the CRM, search a billing system, review previous emails, check a contract, look through a knowledge base, and ask another department for approval. The employee is acting as the integration layer between 6 disconnected systems. An agent could gather that information, identify the relevant policy, prepare a recommended resolution, and route the case to the right person. The CRM still exists. The billing system still exists. The contract repository still exists. But the work of navigating and coordinating those systems begins to change. That is the real disruption.
Traditional software attempts to define the procedure in advance. When this happens, follow path A. When that condition applies, follow path B. When a certain threshold is exceeded, route the transaction to process C. The central engineering question is, did the system execute the logic correctly? Agentic systems introduce a different question. Instead of specifying every step, we may give the system an objective, a set of tools, a body of context, policies, constraints, and boundaries. The agent may decide which record to retrieve first. It may determine whether it needs more evidence. It may choose which tool to call. It may organize its findings and recommend a next action. The engineering question is no longer simply whether the code ran correctly. It becomes, Did the system achieve the intended outcome reliably, safely, economically, and within its delegated authority? That is a much harder standard, and it changes the technology lifecycle. Traditional software development focuses on requirements, architecture, code, testing, deployment, and production monitoring. Agent development adds objective definition, context engineering, tool design, memory, behavioral policies, evaluation datasets, approval gates, runtime tracing, cost controls, and continuous behavioral evaluation. The software development lifecycle is not going away, but it is being joined by an agent development lifecycle. The SDLC and the ADLC will increasingly intersect.
This shift did not begin with ChatGPT or the latest generation of AI agents. It is the result of several transitions that have been happening for years. First, software became modular. Monolithic applications gradually gave way to services, APIs, event streams, cloud platforms, and reusable components. Business capabilities could be invoked without requiring a person to operate the original user interface. That matters because agents need actions they can call. An agent cannot reliably process an invoice as one mysterious action. It needs tools that can retrieve the invoice, check the purchase order, validate the supplier, review the contract, identify discrepancies, update the case, and submit an approved transaction. A P is made business capabilities machine accessible. Agents make those capabilities machine selectable. Second, enterprise data became more distributed. Organizations accumulated databases, SaaS platforms, data warehouses, document repositories, messaging systems, knowledge bases, spreadsheets, emails, and unstructured files. More organizational knowledge became digital, but it also became fragmented. Employees now spend enormous amounts of time searching for information, switching between applications, reconciling conflicting records, and locating the person who understands an undocumented exception. Agents may become a coordination layer across that fragmentation, but this is where leaders must be careful. Agents inherit every weakness beneath them: poor data quality, missing metadata, inconsistent permissions, unclear ownership, unreliable APIs, outdated documentation, contradictory policies. An agent placed over a disorganized enterprise does not automatically create order. It can automate the disorder. Third, foundation models lowered the cost of interpretation. Traditional automation performs best when inputs and procedures are highly structured. Foundation models can interpret natural language, documents, images, code, and loosely structured requests. This expanded the range of work that could be partially automated. Automation was no longer limited to repetitive clicks. It could begin assisting with research, interpretation, synthesis, and exception-heavy work. Fourth, models gain tools. A model that only generates text is primarily an advisor. A model connected to APIs, databases, enterprise applications, browsers, and code execution can become an actor. Tool use is the bridge between intelligence and economic activity. And fifth, organizations discovered that prototypes are much easier than production. A compelling demonstration can be built in a few days. A dependable enterprise system cannot. The moment an agent enters production, the organization must address identity, authorization, privacy, data protection, tool reliability, auditability, evaluation, cost, model changes, exception handling, monitoring, and accountability. The challenge is no longer simply building an agent. The challenge is operating one responsibly inside a real business. A durable enterprise architecture will increasingly contain three interacting types of systems. The first is the system of record. Systems of record preserve authoritative facts and transactions. They include ERP systems, CRMs, banking cores, electronic health records, databases, document repositories, and legacy platforms. These systems should remain controlled, stable, and highly deterministic. The second is the system of action. Systems of action coordinate work across records, applications, tools, and people. Agents increasingly occupy this layer. They interpret objectives, gather context, invoke capabilities, manage exceptions, and recommend or initiate actions. The third is the system of judgment. Systems of judgment determine what should be done, which trade-offs are acceptable, and who carries responsibility for the outcome. AI can support judgment, but institutional, legal, financial, and moral accountability cannot simply be transferred to a model. Human beings still define policy. Human beings approve consequential actions. Human beings adjudicate difficult exceptions. And human beings ultimately answer for the result. The architecture can be summarized this way: systems of record provide truth. Systems of action coordinate execution. Systems of judgment provide authority and accountability. Confusing these roles is dangerous. An agent should not become a system of record simply because it speaks confidently. A database should not be mistaken for a complete business process simply because it contains the data. And human approval should not become ceremonial theater after the machine has effectively made the decision. This shift is more nuanced than saying agents will replace SaaS. There are at least four ways agents will change business applications. First, agents will operate existing applications. They will retrieve information and initiate actions through APIs, events, automation tools, and enterprise integrations. The application remains, the agent reduces the navigational and coordination work around it. Second, agents will be embedded inside applications. Applications will include agents that assist with research, explanation, exception handling, configuration, and workflow support. To the user, the application and agent may feel like one experience. Underneath, they will still have different engineering and governance requirements. Third, agents will replace portions of the interface. Many screens exist because users must translate what they want into the rigid structure a computer expects. Agents reverse that relationship. A user can express an intended outcome in natural language, and the agent can translate that objective into actions across multiple systems. That could reduce the need for certain dashboards, forms, menus, and workflow interfaces. But the transactional systems behind those interfaces will often remain essential. Fourth, agents will help build and maintain the software itself. Development agents are already participating in planning, code generation, modernization, testing, documentation, debugging, and deployment preparation. This creates a recursive effect. Agents are becoming a new kind of enterprise system. At the same time, agents are helping produce the traditional software, integrations, and APIs on which other agents depend. A durable enterprise architecture will increasingly contain three interacting types of systems. The first is the system of record. Systems of record preserve authoritative facts and transactions. They include ERP systems, CRMs, banking cores, electronic health records, databases, document repositories, and legacy platforms. These systems should remain controlled, stable, and highly deterministic. The second is the system of action. Systems of action coordinate work across records, applications, tools, and people. Agents increasingly occupy this layer. They interpret objectives, gather context, invoke capabilities, manage exceptions, and recommend or initiate actions. The third is the system of judgment. Systems of judgment determine what should be done, which trade-offs are acceptable, and who carries responsibility for the outcome. AI can support judgment, but institutional, legal, financial, and moral accountability cannot simply be transferred to a model. Human beings still define policy. Human beings approve consequential actions. Human beings adjudicate difficult exceptions. And human beings ultimately answer for the result. The architecture can be summarized this way. Systems of record provide truth. Systems of action coordinate execution. Systems of judgment provide authority and accountability. Confusing these roles is dangerous. An agent should not become a system of record simply because it speaks confidently. A database should not be mistaken for a complete business process simply because it contains the data. And human approval should not become ceremonial theater after the machine has effectively made the decision. So, what should executives and technology leaders do now? First, classify the work before selecting the technology. Most enterprise work falls into three broad categories. The first is stable, high-volume, rules-based transactions. That work generally belongs in deterministic software. The second is ambiguous, exception-rich work requiring coordination across multiple systems. That is often a strong candidate for agent assistance. The third is consequential decision-making that requires accountable human judgment. AI may provide research and recommendations, but human authority must remain deliberate and real. Second, identify where the business logic actually lives. Organizations often assume that the process is contained inside the application. In reality, critical business logic may be scattered across code, spreadsheets, policy documents, emails, employee memory, and informal workarounds. Before deploying an agent, identify the authoritative rules, systems of record, required evidence, decision rights, exceptions, escalation paths, and prohibited actions. You cannot govern an agent with rules the organization has never made explicit. Third, build reliable tools before granting autonomy. Agents need narrow, dependable, well-permissioned tools. A tool that retrieves a claim, validates an invoice, or creates a draft case should have a clear purpose, constrained permissions, predictable error handling, and auditable outputs. The quality of an agent is limited not only by the intelligence of the model, it is also limited by the quality of the environment in which the model operates. Fourth, treat evaluation as a permanent capability. Traditional testing often asks whether a known input produces the expected output. Agent evaluation must examine much more. Did the agent complete the task? Did it select the correct tools? Did it use reliable evidence? Did it comply with policy? Did it behave consistently across repeated runs? Did it escalate uncertainty appropriately? How much did the outcome cost? How long did it take? Because agent behavior can vary, evaluation cannot end when the system launches. Production monitoring is not optional. Fifth, design meaningful human control into the workflow. Human in the loop is not a complete governance strategy. Leaders must specify which actions require approval, who is authorized to approve them, what evidence the reviewer receives, and whether that person has enough authority and time to disagree. They must also define what happens when an action is rejected and who ultimately owns the outcome. A human approval step is meaningless if the employee is simply clicking approve on hundreds of AI generated decisions each day. Finally, measure value across the entire system. Do not evaluate AI only through model accuracy, token usage, or lines of code generated. Measure whether the combined solution improves cycle time, exception resolution, revenue capture, customer outcomes, employee workload, compliance, resilience, and cost per completed outcome. The most important economic unit is not the token. It is not the agent. It is not the software seat. It is the successfully completed business outcome. Every major technology era changes what organizations consider scarce. In the early software era, computing power was scarce. Later, packaged applications were scarce. Then, integration expertise, cloud talent, data science, and digital experience became scarce. Generative AI is making the production of plausible content and increasingly plausible code less scarce. But it is not making judgment, accountability, trustworthy systems, organizational knowledge, or reliable verification abundant. Those capabilities may become more valuable precisely because generation is becoming easier. The future will not belong simply to the companies that deploy the most agents. It will belong to the organizations that understand what should remain deterministic, what can be delegated, what must be continuously observed, and what must remain under human authority. IBM's current financial warning may ultimately prove to be a temporary disruption. One quarter can reflect budget timing, execution problems, delayed deals, product cycles, or temporary market pressure. But the deeper architectural signal is unlikely to disappear. Enterprise technology spending is being reordered because the enterprise itself is being reordered. Software will remain, applications will remain, data platforms and systems of record will remain. But around them, a new operational layer is forming. A layer in which agents interpret objectives, gather context, invoke software, coordinate work, and collaborate with human beings. The central leadership question is no longer simply, where can we add AI? The better question is, how should work, intelligence, software, data, and human responsibility be recomposed now that machines can participate in the process instead of merely executing the program? That is the shift, and the organizations that recognize it early will be far better positioned to navigate what comes next.